Welcome back. This is Mr. Greenstein's Geometry, and we are in Chapter 4, Section 6, Similarity and Transformations. So what can you say about these geometries? Well, just take a look at it. You probably recognize that this is the state of California, but I have a small state here, and then a little bit larger one over here. So it's been dilated. But you can still recognize it because you can see that all the side lengths are the same and all the angles or all the side lengths are similar and the angles are the same. If I enlarge it and then flip it, it still looks like the state of California. It's just on its head. So all of these you could say are similar. Similar geometries are two figures that have the same shape but not necessarily the same size. So these all have the same shape. A similarity transformation is a dilation or a composite of rigid motions and dilations. So as we're going to add to our rigid motions, our isometries, we're going to add a dilation in there, and that will keep it similar. It's congruent if you only do rigid motions, but if you add a dilation in there, either make it smaller or bigger, then it's similar. So it's a similarity transformation. So two geometric figures, are similar figures if and only if there's a similarity transformation that maps one figure onto the other. And you can see that the transformations that would happen here is that you would have a rotation and then you would have a dilation. And that works so that these are similar. Here, we're going to graph ABC. So A is -4, 1, and then -2, 2. That's B. And -2, 1. So a very small geometry here, ABC. So if we map these through a translation, we're going to add 5 and 1 to each one of them. There's one. There's the other one. So this is a translation. And then a dilation, we're going to make it 2 times this. So 2 times for A is going to put it out here. I'm going to use a different color here. This is 3 and 3, so it's going to be 6 and 6. And, whoops, 6 and 6. And then there's 3 and 2, so it's going to be 6 and 4. So there's our new figure. So a translation and a dilation, that means that when we're going from this figure here to this figure here, they are similar figures because we used a translation, which is an isometry, and we used a dilation. Describe the transformations. Well, if we're going to go from this large figure here down to this small figure here, one way that we could do it is that we could dilate it in half, or actually in a third, and then reflect it across the y-axis. So if we dilate it down, making it smaller, and then reflect it, then we get this new figure over here. Why don't you calculate what the dilation scale factor is? Now we want to prove that these two squares are similar. The way that we can do that, this square has side R on each side, and this has S on each side. What we can do is we can do a translation. So we can move this over to here, and we'll get something that looks like this. And then we do a dilation, And then the dilation then makes it this big. And by doing those two, then we have shown that these two are similar. So first a translation and then a dilation. And that's how we could prove that these are similar figures to each other. And with that, we are finished chapter 4. We will talk about the rest of this in the next day of class.